welcome to the Graph's Mission Control second indexer call. If you missed the first call, don't worry. We recorded that one as well, and we will be sharing that after this call. This is also being recorded. So like I said earlier, if you don't want to be recorded, please just turn off your video and hide your name. I know it's very late in some parts of the world and also very early in others. So thank you all for being here. My name is Tegan Klein. I focus on GRT relations as well as business development at the Graph. If you ever have any questions at any point during the testnet, just let me know. If I don't have the answer, I will find an answer for you. And it's with my great pleasure to introduce Giannis, our co-founder and tech lead here at the Graph.
Thank you, Tegan. Hi, everyone. Glad so many of you made it around the world. So this is the Mission Control Indexer workshop, where we'll walk you through, well, first of all, the phase 0 mission and in requirements, which includes, the infrastructure that we expect you to set up as indexers, as well as a number of useful things like how to monitor your setup, how to configure your setup, and so on. So for those of you who've filled out the indexer agreement already, you'll have been invited to the Mission Control Indexer repo, which contains some documentation to get started, primarily like the rules for the mission for phase 0, as well as infrastructure templates for Terraform and Kubernetes. So I've already seen on Discord that many are going bare bones instead of going with Kubernetes or Terraform or Google Cloud. That's all fine. You don't need to follow those instructions or those templates. They are primarily intended as something that you can look at for reference, how things are wired up, what kind of ports are exposed, and how and what kind of environment variables you can tweak, or like where to put them. So we're gonna go through phase 0 to start with. And phase 0 is the first, or there's one mission included in phase 0. And this mission ends on August 12th, end of day, I think Pacific time. And so that is, I think, about 8 days from now, so next Wednesday, if I'm correct. And we will then take a couple of days or so and some time over the weekend to evaluate all the submissions, test drive your setups a little bit, and then we'll announce the results from that mission on, I think August 7th is Monday morning Pacific time. Cool, so what's in the mission? The mission is primarily to deploy the initial infrastructure, which we will extend upon in the following phases. And we'll go into detail what this initial infrastructure looks like, or can look like. There's different ways to do it. You have then the mission to index a small selection of subgraphs. So we've picked 3 different subgraphs with different sizes and different requirements that we would like you to index. So that will just give you an idea of what a subgraph is, what it's what you can observe when it's running, how how much time it takes, what the graph node looks like when you look at the logs, etc. So it'll give you an idea of what it's like to run a graph node and to work with these subgraphs, because you'll need to be familiar with the subgraph for the levels to understand what they are and what it means to index them. Along with that, we'll expect you to share a couple endpoints. It could be one that combines everything we need with the team, with our team. And one of them is a Prometheus endpoint that exposes metrics from your graph node. And the other is the graph node itself, so that we can hit that with queries. And we then, during this test driving of your setups, will then expect you to be able to serve about 10 queries a second with a very small error rate for those queries. Now I've seen that somebody posted that what happens if my infrastructure provider goes down or something and I can't meet that error rate. If there's issues, temporarily, let us know, and we can rerun our test, basically. So don't worry about that too much. This is primarily to test that you have set up things correctly and that your graph node isn't constantly crashing, that kind of stuff. Okay. If you have any questions like during this workshop, we'll have a Q&A session at the end, or like some time at the end. But if you have some questions, please post them in the chat, and I think the team will field them and bring them up with us as we go. So if there's anything that you have a question about, please shout up. Well, we'll post in the chat. Cool. So that's the mission for phase 0, including the timeline. Let's take a closer look at what the infrastructure is that we expect to be deployed for this phase. So we're going to start relatively simple with the graph node, which is kind of the main workhorse in the protocols that does all the indexing work, prepares all the data from the subgraphs in the database, and can also serve GraphQL queries. And so we expect that to be deployed along with Postgres. Please use a recent version of Postgres because that will make it easier to migrate going forward if that ever needs to happen. So Postgres is the other thing. So Postgres is a database, pretty mature, stable, and fast, and very versatile database that graph node uses to store all the data and also to query the data. And then the third component is Prometheus, and that's not all may be familiar with Prometheus, but it's a very it's a very convenient way of tracking metrics from or like gathering metrics from various system components, putting them into a time series database that you can then easily query to generate dashboards and so on. So that might also help you internally to observe what's going on in your cluster or in your setup. There's one more component that's not mentioned here, which is Grafana. We'll get to that. And then, of course, to do any indexing from Ethereum, you'll need either run your own Ethereum archive node, or you'll need to use an external provider or like a node run by somebody else. That's of course required, but we don't mandate whether you have to run it yourself or not. So that's up to you. And that's it for the infrastructure, right? The 3 subgraphs that we've picked for phase 0 are Moloch, Synthetics, and Uniswap. And we've picked them for different reasons. So Moloch is a rather small subgraph with about 1,000 entities. So entities, you can think of that like as a database record or an object. So Moloch has like votes and proposals and so on. There's not that many of them. So that should be indexing within a few hours. And that'll give you some early feedback, how things are going, and it'll just be hopefully rewarding to see that index and to be able to query like the final state of that and to see like following the chain as the chain grows. Probably take less than an hour. I'm not sure. I haven't tried it in last week. Then the next one is synthetics. I'd call that a bonus. So not everybody will be able to index that one because it requires the Open Ethereum Trace API, which Geth doesn't implement. So that's bonus points on the leaderboard. It's like medium-sized, has like 1.6 million entities or database rows, and should index in a few days, probably around 1 or 2 days. I think more like 2. And then we have Uniswap, which also requires a mainnet archive node like the others. Doesn't require traces, but it is a fairly huge subgraph, creating 4 million entities, and should also take a few days to index, although the team has created a new version. So that's Uniswap v2. They have created a new version that I think might index a bit faster. So you'll see. But Moloch will be the one that you'll see finishing first, and it'll be nice to see. So those are the 3 subgraphs, and the Moloch and Uniswap subgraph, those are required to be indexed as part of this phase. Cool, so let's dive into the infrastructure a bit more in detail. So how are things wired up? And you can think of this infrastructure as being scalable. So you could start with the basic infrastructure, which would be totally fine for phase 0. So you'll have our kind of test harness that we run on our side, and you'll expose a Prometheus endpoint to us and a GraphNode query endpoint. And GraphNode will push metrics into your Prometheus instance and will use Postgres to store and read data while it's indexing and while we're querying it. Then the GraphNode is the component that talks to, is connected to Ethereum. That's where the Ethereum archive node comes into play. And that's where it makes calls such as filtering logs for block ranges up to the current chain head, where it makes contract calls for historic state in the contracts, and all of that gets put into Postgres depending on how the subgraphs are structured. And then the Grafana is kind of the you could call it optional. It's included in the example setup that we've provided, but this will be useful for you as well. So Grafana is, you can think of it as UI for various like metric type data sources. So you can configure it with Prometheus, and then you can use the Prometheus metrics to see, for instance, what your graph node is doing. You can also push, I think you can push logs into it, although we are not really doing that right now, but you can connect it to like Postgres directly as well. And so Postgres can push metrics into Grafana as well, or Grafana can pull Postgres for metrics. And that'll give you a nice tool to monitor your setup. So this is the basic setup. What we recommend is to be at least prepared for scaling this up for future phases. So this is similar to what we do on the hosted service as well right now, where we are indexing about 1,500 subgraphs right now, probably more by now. And so we've basically done two things here compared to the basic infrastructure. One is that we've horizontally scaled. Well, okay, let me start with another thing first. So first of all, we've split up the graph node deployment into two sets. One is the query nodes, and one is the index nodes. The query nodes just handle queries. They don't do any indexing work. So when it comes to the database, all they do is read. And all the queries that come in from the outside get sent to a load balanced set of query nodes. And then we have the index node set, which only does indexing work. It's not used for querying, except for reads that happen as part of indexing. The reason we've done that is so that we can scale the query nodes up and down depending on query volume traffic coming in, and same with the indexing. Depending on how many subgraphs there are that we want to index, we can scale up more. We can bring up more index nodes, or shuffle these around a little bit. We can also create dedicated index nodes for specific subgraphs if they are really, really expensive and kind of have a negative impact on everything else. So that's a nice property. The other reason to split these up is that they have rather different CPU and memory profiles. So like an index node, for instance, will require a lot of memory or more memory than usual when there's heavy indexing work to be done and a lot of subgraphs are deployed at the same time. The query nodes, on the other hand, will require more memory when there's more queries coming in. So they have very different independent memory profiles and CPU profiles. So this is something that I would recommend preparing for, because that'll allow you to stay flexible as we increase query traffic in the upcoming phases. Yes, so that's that. I'll now hand it over to David, my colleague, who will walk you through the Terraform and Kubernetes example setup that we've prepared for you in the mission control indexer repo.
Hey everybody, let me share my screen. Thanks, Janis. Okay, so what I'm going to do is, you've all seen the mission control repo, I assume, or the ones who have signed up have seen it. The main things it contains right now is a Terraform manifest to set up the basic infrastructure for an indexer, and the Kubernetes manifests that then create workloads. And so rather than go through those manifests, because there's a lot of detail and it's a little tedious, I'm just going to go through what you get once you've run through all of these things. And especially the Terraform setup is made for Google Cloud, but I would look at this more as executable documentation rather than sort of a prescription or even a recommendation of where you should run your indexer. We actually encourage having as much variety in terms of infrastructure as possible. And it would be great if people want to collaborate on translating what we have there for different clouds or bare metal setups, different kinds of running indexers. All that would be awesome to get out of this phase. But as Janne said, the main point of this phase is to get everybody acquainted with running an indexer and the basic graph node setup. Okay, so let's just go through what we set up in Kubernetes to run an indexer. We run a Grafana, which if you haven't used it, it's a way to create dashboards. Now we'll look at some of the dashboard, or one of the dashboards in a minute. Then we have an index node and a query node, which are the things from the graphics that Jannis just showed for handling indexing and querying. We have a Prometheus, which collects metrics, and then we also have an NFS server that's only used to catch crash dumps. So in the highly unlikely event that graph node should crash, we have set things up so that a core dump gets copied to the NFS server so it can later be analyzed. But you don't have to run that, and there are hooks in the various Dart scripts that make everything work, even if you're not going to catch crash dumps. And then finally, there's a shell container, which just gives you a convenient way to sort of get into your cluster and do some things from the inside. Most importantly, that shell container has a couple shell scripts installed that you can use for simple management tasks, like deploying a subgraph easily. Okay, the next thing to look at, and something that you will have to look at once you set up your own infrastructure, is the services, what network things does Kubernetes expose. I'm sorry. You want to write down the IP address for the query node. That's where you send GraphQL queries. This one here, this IP address here is for the Grafana dashboards, and you might want to restrict that to just internal use that doesn't need to be exposed to the world. And then finally, there's the indexer, which gives us access to Prometheus. So that's something you need to share with us. I'm not sure if the form has gone out yet, but there will be a form that asks for that information. Okay, so that's it for sort of the basic Kubernetes dashboards. The Grafana that we lay down with the Kubernetes installation comes with a few dashboards that we found very useful in our hosted service. There's a few dashboards in there. I'm only going to look at one because that's most pertinent for sort of getting started and seeing what your indexer is doing. There's other ones, but they're more useful for troubleshooting performance, and we'll get into those in workshops for other phases. Okay, so the indexing status dashboard gives you an overview of which subgraphs are deployed currently with their name and their subgraph ID. This schema here is where in the database the data is stored. Hopefully you never have to worry about what that actually means. The ID of the node that's running, that's indexing that subgraph, whether that subgraph is synced or whether it's still catching up with the head of the ethereum chain, the network it's on, and how many blocks that is currently behind. And the blocks behind, and the lag, that's just sort of how far you're behind translated into time using average block times. The blocks behind is based on our understanding of where the head of the Ethereum chain is, which may or may not coincide with what the rest of the world thinks where the head of the Ethereum chain is. And there's another panel down here. I can scroll to it, about network head blocks, that shows you what we think currently what the head block is of mainnet, for example. And you can use that information to check whether, what we think the mainnet head block is coincides with what your index, your Ethereum node thinks, or Etherscan, or whatever your favorite way of figuring out where the Ethereum chain is currently. And so a discrepancy here, I mean, a few blocks is totally normal, but a discrepancy here usually means you're having trouble ingesting blocks. And large discrepancies here for subgraphs that say they're synced usually means there's something wrong with how the subgraph is processing data. Okay, another thing that is part of GraphNode is the indexing status API. And if you go, the IP address of your index node, your index node, and /index node GraphQL playground, you get a graphical interface. Graphical is a really nice tool to interact with GraphQL interfaces. It comes with docs where it shows you the GraphQL schema, so you know exactly what queries you can send. And this query here asks for the live peer subgraph. Where do we think the chain is? Where do you think the subgraph is? What's the network? And what's the name of the indexing node that's running it, and whether it's synced. And there's lots more information you can get out of this. So that's sort of another, like for your own monitoring tools, this might be really useful. We use it in the gateway to figure out where different indexers are, and whether their data is fresh enough to sort of say run a query we got. You can also inspect the data for a subgraph with a similar GraphQL interface. That's at subgraphs name and then the name of the subgraph /GraphQL. That also has the schema for the subgraph, which is derived from the subgraph's input schema, what is part of the subgraph when you define a subgraph. And so you can ask live peer what transcoders it knows about. Graphical has a nice sort of auto-completion built in, see if they're active. If you suspect that there's something wrong with ingesting data, you might want to check for some subgraphs what the data is. Okay, so much for sort of what happens when you run the Terraform and Kubernetes manifests. Let's just have a quick look at the repo. In there are two directories, a K8s Kubernetes directory and a Terraform directory. The Kubernetes directory in turn has two subdirectories. The base directory is something that we will expand over time as the testnet progresses. We have the files for phase 0 in there. For future phases, we'll have more services that will add to the Kubernetes setup. And the custom directory has sort of template files that you should modify, like the Ethereum networks file. You list here what Ethereum, where your Ethereum provider actually is, your Ethereum node. And it has instructions on how to set everything up. I mean, the setup is super simple. Once you have a Kubernetes cluster running, it's just apply. And at the bottom, it also explains what these management shell scripts in the shell container are and how to use them. So the important thing here is that don't change things in the base directory. You'll get merge conflicts in future phases. Make all your changes in the custom directory. And then the Terraform directory has, this has very detailed instructions about how to set up a new Google Cloud project and run Terraform to get the basic infrastructure, all the virtual machines and database and whatnot that you need to then deploy the Kubernetes workloads. Besides the instructions, the most important file here is this variables file, where you define what your Google Cloud project's called, in what zone it lives, what you want to call your indexer, and things like what size virtual machines to use for query nodes and index nodes, what size of database to use, what the database password is, and so on. And then the main TF, that's the actual Terraform manifest. With all this stuff, as I said, it's more executable documentation than the strict requirement. So we really want you to read through all these things and try to understand what they do, at least at a high level. and not just run these things and hope for the best, because you will need that understanding later on when it comes to operating the cluster. Okay, that's all I was going to cover, and I'll just hand it back to Yannis.
Cool, thank you, David. All right, so let's get back to the infrastructure, or the rest of the infrastructure. So as far as the Ethereum node or nodes go, the minimum that's required to complete the testnet, so that includes later phases, is a mainnet archive node. So that can be Geth, Open Ethereum. We haven't tried others. So I've seen that a few people have suggested Nethermind or TurboGeth. If you have a node like that running and you would like to vet us, you'd like us to vet that node a little bit, if you could send us a URL, we can inspect that a little bit and see if it's suitable. Ideal for the testnet is a mainnet archive node that has the Open Ethereum Trace API enabled. This is because a lot of subgraphs use a feature called call handlers, which requires function or call traces. And we currently only support the Open Ethereum Trace API to get those. If you have such a node, that means there's a few subgraphs that you can index that people who don't have a trace node might not be able to index, and that might give you an advantage when it comes to making a profit from indexing subgraphs, because we will generate query traffic for those subgraphs, and only those who can index them will obviously be able to serve those queries. But having said that, you can run from start to finish with a regular mainnet archive node. Bonus points if you run your own archive node, but generally we don't want to limit what you're doing anyway. So you can use your own, you can use a cluster of own nodes, you can use a provider. There's been some discussions on Discord already about what's available out there. If you want to run your own archive node, keep in mind that it may not be feasible to sync that for phase 0, because syncing the mainnet archive node can take a few weeks. So yeah, keep that in mind. Perhaps you still want to do it and you want to use that in later phases. That could work, for instance. One other thing, so yeah, Ethereum nodes. So one thing you may want to also prepare for is to horizontally scale those Ethereum nodes, so that you can distribute the load across them when indexing. That can definitely help, because the nodes do a lot already just by syncing and staying in sync with the chain, and this is extra work they have to do. So it's nice to be able to distribute that load a little bit. Okay, so we're moving on to a bit of resource guidance. Many have asked on Discord kind of what like hardware requirements are set for the testnet, and we'll give you a bit of guidance on what you can expect to have to run for the testnet. And David, do you want to walk us through this?
Sure, yeah. So we've put together basically 4 scenarios for the size of the infrastructure. Small is what we are using for some of our regression testing infrastructure. That's good enough to get you started in the testnet. The standard is what you get when you set up the Kubernetes manifest and the Terraform stuff that I just talked through. Medium is sort of a pretty big setup that we used to run in production for a long time. And then kitchen sink is just there to show you how big it could possibly get, but you're not going to get there in the testnet. And all these machines and all that are from Google Cloud, just for reference, so you know what vCPU and all that means. Okay, I think that covers it.
Yeah. Somebody, I think, asked in the chat whether Postgres was included in the Kubernetes setup. It is not. This setup, as we mentioned, is intended for Google Cloud, and so there's a pretty nice component in Google Cloud called Cloud SQL. So that moves the database out of Kubernetes, and I would encourage, I think, to keep the database separate in some way. So I wouldn't like put it in, let's say, in a Docker Compose environment. I probably wouldn't put Postgres in a Docker Compose or Docker container in there, because the database is among the things that I use the most, and I like have to be very stable and also require the most resources. So it can make sense to keep that separate. Which is also why we have the VMs and memory divided here. Okay, let's move on. So depending on whether you run your own Ethereum node or use somebody else's, you may wonder about like what kind of bandwidth is required for that. So for phase 0, which is the 3 subgraphs, we're definitely expecting to stay below like 1 million requests per day for indexing those. And also you probably won't have more than 20 gigabytes of, IO going through the network just to get the data from the Ethereum node. For later phases, we expect, depending on how many subgraphs you are indexing in later phases, of course, but we expect that to go up to like 3 to 4 million requests a day to the Ethereum node or provider, with a traffic of about 50 to 80 gigabytes a day. There is also a lot of information cached by graph node that will not be like requested again later, but still the more subgraphs you index, the more requests to Ethereum are being made, which is partly why I suggested the load balancing or like horizontal scaling for Ethereum if you run your own nodes. Okay, we're moving on to how you can monitor your setup and what's very useful to do so. So first of all, GraphNode has pretty extensive logging and structured logging at that. So all the log messages look, once you've seen them a bit, they all follow kind of the same structure, and you can probably recognize them pretty easily at some point. And we're logging a lot of the indexing information for every subgraph, but also block ingestion. That is kind of the driving force of like how, based on how the chain or the chains grow, and those can be searched. So those logs can be searched pretty easily for specific things like the subgraph deployment that may be failing on your node and you don't know why, or block numbers to understand what happened at a certain block. And I think I may have terminal open for that, just so I can, one sec, I think I can just show you the logs really quick. Graph nodes, so this is container. Okay, this one doesn't have a lot of information. Okay, I can't right now, but if you search for instance, this is a subgraph deployment ID, all the log messages for when that's indexing will have that ID. So you can search them all by just grabbing for that ID in the logs, for instance. Another thing that we support, or that GraphNode supports, is to log to Elasticsearch. So that gives you just another tool to inspect the logs and organize them and filter them, and build up an analytics pipeline for the log based on the logs. Elasticsearch can be configured, I think, through the CLI args in GraphNode for sure, but I think also environment variables, so you can just define it if you use Dockerized environment. Yeah, I think subgraphs on average not entirely sure, but they will log a few million messages. So that log volume can grow pretty substantially. So keep that in mind. In addition to investigating the logs, which is kind of the most low level and bare bones way of analyzing or monitoring your environment, so better way or like a more high level way are metrics. There's a few metrics that we've come to find really useful to just know what's going on in the cluster and how healthy it is. One is to create metrics based on the response code of queries being made, specifically successful queries. So HTTP status codes in the range like 200 to 299, as well as like HTTP response codes of 500, 502, 504, and I'm not sure how like Amazon does it, like, or AWS does it, for instance, but at least with Google Cloud, you can pretty easily create metrics based on logs by filtering logs and then I think transforming them a little bit. So that's been useful, and then that gives you an idea of the query traffic that you're receiving and how many of those queries are successful and how many fail due to maybe the infrastructure being overloaded. Another good metric that is a good proxy for how busy your system is query latency. And what we've done in our internal dashboards is that we're tracking them by like average query latency, median query latency, and the 95th percentile latency. And that gives you a good idea of how long does it take to execute queries on average, or like what's the really most expensive queries that are being run. That'll give you a good idea of like how slow, for instance, clients would be if they were querying your infrastructure. Other good metrics are CPU load for query nodes, for the index nodes, and for the database. Especially the database gives you a good idea about how much load there is on your system, primarily query-wise. The query nodes also give you an idea, the more busy they are, the higher the CPU is, the more query traffic you're likely receiving. And the same goes for memory usage. And then there's another metric that we can recommend, which is query node cache hits, to have an idea of how many cacheable queries you're receiving and how many queries are not cached, because that can also vary over time. There's a built-in cache in Graph Node, or if you set up different, like a separate query node, then in the query node that caches queries per block by default, or like all the, if the same query comes in within the same block, still being like the latest for a subgraph, then those will use a cache result if possible. And so for like that metric specifically, and also to get an idea of the query times that you're seeing, which is very similar to the query latency, but the query latency can also include networking in your infrastructure. The GraphQL query logs are really useful. Those look roughly like this. I've formatted this a little bit so it's easier to read, but this is usually one line. And there you can, for instance, identify how many cache hits, misses, or like inserts you're seeing. There's also shared cache for when the same query comes in multiple times in parallel, and they haven't been cached yet, that only one of them is executed and the others wait for that result and they all get the result together. That's the shared cache. And then the query time in milliseconds is also a good indicator of like how slow specific queries are, for instance, or if you want to get an idea of what the overall time spent on executing queries is, that's the thing to look out for. Okay, let's move on to what the different means are to configure your infrastructure. And this is independent of whether you use Terraform or Kubernetes. There's obviously specific ways to configure Terraform and Kubernetes, but Most of this applies to your, or will apply to your individual setups as well. The primary way of configuring, for instance, graph node, if you use a Dockerized environment, is through environment variables. And we've documented most of them. Let me quickly point you to that information. So if you go, I think it's also linked from the mission control indexer repo on the environment variables. If you go there, that takes you to this directory, specifically this file. And there's a lot of environment variables that you can use to, for instance, tweak how the node is pulling information from the Ethereum nodes, like how many times it checks for a new block on chain, which for mainnet you can set to a pretty long time, but for networks that have very short block times, you might want to configure that. The testnet doesn't really apply. But there's tweaks, for instance, like how many parallel requests do I send to the Ethereum node? How many, like how do I tweak the range of blocks I scan for events for a specific subgraph or for like any subgraph? Because some Ethereum nodes, we've learned the hard way, don't support very large ranges, for instance. So we've implemented like adaptive resizing of the ranges that we're scanning, but and that's, for instance, based on this environment variable, based on the amount of events we find in the last range. And so you can configure a number of things here to make sure that the Ethereum node that you're using can deal with the requests you're making, and a graph node can progress nicely. There's other things like limits for how long subgraphs should be running, let's say their data transformations, their mappings, what the maximum file size is that you want to allow for reading from IPFS, that kind of information. There's environment variables to tweak how you deal with queries that come in, specifically, what the max depth of queries is allowed to be, pagination limits, complexity limits, that kind of stuff. And then there's a number of database related environment variables, like the connection pool size allows you to scale the connections that you're establishing with Postgres. The default is 10 for each for the connection pool. And then there's some load management environment variables in here. That is a relatively new feature that allows you to dynamically deal with high query load, and allows you to reject queries when the node is or when the cluster is too overloaded. And I think there was some more for the caching, but that doesn't have to. Maybe that's still in review, so we'll add that in as well. Let me quickly go back to the slides. Yes, so then in addition or as an alternative to environment variables, you can also use command line arguments if you, for instance, run graph node yourself, right? Maybe you don't want to use a Docker image, maybe you want to run graph node yourself. I think there's more flags by now, but essentially a lot of the environment variables to configure, for instance, Ethereum or Elasticsearch for logging and like what ports you're using or exposing, you can pass in as command line arguments when you run the node. Although many of those more fine-grained tweaks are not exposed here, but are just environment variables. And then there's, for Ethereum specifically, there's a config file. It's also very new and is very basic right now. But you may be using an Ethereum node that is protected by HTTP auth, for instance. So like basic auth or like an auth token, or you may have to provide specific headers. So that's where you can come in and you can create an Ethereum config file, and you can set an environment, and you don't even have to set an environment, but you put that in a certain place in your file system. And you can then override or add HTTP headers that are being used to when making requests to specific Ethereum endpoints that you're using. So that is possible. What I'm not mentioning here is that when you run a graph node and you just go to the Kubernetes setup and the Ethereum networks, a new thing also that we're now offering as part of Graph Node is something called node capabilities, Ethereum node capabilities. So in addition to just saying what network a node is for, in between here you can say whether it supports archive, tracing or traces, or just a subset of those. That allows you to connect to multiple. So generally you can connect to multiple Ethereum networks or Ethereum nodes per network. That's one thing. But you can also specify different capabilities for those. So if you have one provider that does traces and one provider that doesn't, you can combine them and you can say which capabilities each of them have. And that'll make everything work nicely. So that is the basics of how you can configure Graph Node itself. So yeah, we've gone through most of those. One of those particularly will be interesting, which is the node ID. We'll get to that in a moment. So yeah, this we've already covered. Yes, so I've shown you that there's two general ways to think about a graph node deployment. You can have a single graph node. You can have index node and graph nodes split up, and then you can also scale index nodes horizontally. When you do that, which I think we recommend, but not for phase 0, you can also start simple there, is that you will need to establish only one of those index nodes as the so-called block ingester. So that's the component that fetches the blocks, like the latest block from the network, and makes sure to stay on top of that and kind of drives all the subgraphs forward. If you have multiple nodes that do that, you're mostly wasting resources. I think nothing goes wrong. I might be wrong about that, but it's definitely a good idea to only have one of those do the block ingestion. The second really important factor is that each of the index nodes you're running has to have a unique graph node ID. So that's passed in as a command line argument or as an environment variable. You find that in the docs. That's important because that then allows you to assign different subgraphs to different nodes. And that way you can distribute the load evenly or by, based on CPU usage, etc. But it's really important because if you don't have unique node IDs, that would mean that two nodes might race on the same subgraph, and that definitely leads to problems. So very important to do that. In the Kubernetes setup, that is included in the repo. This is already done just by using more or less the pod name. Kubernetes pods are like instances as the node ID, so that it's done automatically. Whoa, that was quick. Okay, so we're through. Oh well, I say quick. It's been 50 minutes. So we're through like the walkthrough, and we can open it up for questions.
Yeah, so we've had a lively discussion in chat. I think there have been some recurring themes around costs. Do you want to just maybe give people a sense for, how the hardware, I think, David, you already had this on one of your slides, but maybe just kind of reiterate like how the hardware requirements might vary across, the number and types of subgraphs that you're indexing and what people can expect there.
Yeah, I mean, it varies a lot along different axes. Like, it's not just the number of subgraphs. There's also a marked difference between sort of how difficult the subgraph is to index. There's some subgraphs that you won't even notice, and other subgraphs where like, wow, this is really hard. In general, once a subgraph is caught up, what we call synced in those dashboards or in our APIs. Once subgraph is synced, it's pretty light on the system. It's really just the syncing activity when you deploy a subgraph and it catches up to the chain head that makes indexing expensive. In terms of queries, there's also, unfortunately, a pretty broad spectrum of queries you get, just because our GraphQL interface lets write people free-form queries that can be very difficult or very easy to respond to. What we see in the hosted service is generally we have like a median execution time of around 150 milliseconds average, or in the 250, 300 millisecond range, but a fairly high P95 of like 1.5, 2 seconds, just because we have this broad spectrum of queries. I would say that the most important takeaway, I think, is be prepared to scale along all these axes that we mentioned. Be prepared to scale your database, be prepared to scale your index nodes and your query nodes separately. And the one point of the testnet is for indexers to sort of acquaint themselves with how the system behaves under load and with varying numbers of subgraphs and varying subgraph difficulty.
Great. So we had another question, I think, was asking about the drop rate that we have in the requirements. So I think it's like I think it's listed as like 0.05% for phase 0. I guess I want to address that because I think the comment made a point of like, well, if my ISP drops out for a minute, or am I out of the testnet? So we're not setting these requirements as like gotchas. We're not trying to we want people to get through these phases. Like we see ourselves as kind of collaborators with you on this. So like if your ISP drops out, we'll run, the test again, but that's just kind of the baseline of where we want, where we think folks will actually want to be by the end of phase 0 to even just be competitive later in the testnet. Because keep in mind that, this is run as like a decentralized market. So if you're running an indexer with that's dropping queries left and right, just by the dynamics of the market, your indexer is not going to get selected for query traffic. So this is us kind of helping, you get to a baseline where we can figure out if it's worth your time to kind of keep, participating in the more competitive phases of the testnet. So it's not meant to be a gotcha. We're just kind of trying to make sure everyone's, prepared. So we have another question from Hadrian. I think addressing your point, David, does it make sense to scale the ingester nodes that much? My understanding that subgraphs can only be indexed by a single indexer, so having more indexers won't help handle big subgraph like synthetics or Uniswap. So that's correct. Yeah. Usually it's one subgraph per indexer.
Yeah, I mean, that's sort of the smallest you can possibly do, right? Like one subgraph per indexers. The actual processing of subgraphs also has some parallelism in it, although that's fairly limited just because of the nature of that we need to go through the data sequentially to guarantee determinism of the result. But some degree of increasing the size of the machine or the speed of the machine can help. Increasing memory, I mean, if you don't have enough memory in your machine, that can also make a difference. But yeah, I mean, there is a limit for indexing that where you can, how much you can scale. Having said that, we haven't had any trouble with that. Like, any indexing issues we've had have mostly been with, some other faults, right? Like, we're not ingesting blocks at all. Like, we haven't had to ingest the block ingester at all. That thing, any problems there are sort of network connectivity or bugs or something like that we've encountered.
Yeah, database connections not being sufficient. Yeah.
Oh yeah, that's an important point for scaling. By default, each graph node instance gets a database connection pool of 10, and that can be too little. Like if you, for example, like you can index like 100 subgraphs on one index node, but you need to give that index node more database connections, otherwise you get slowed down by them all fighting over who gets the database connection.
Yeah, and then it also depends on, like, if the more connections you need, you know, the Postgres instance may have to be scaled up a little to handle that number of connections. Yeah.
Great. So we've got a handful of questions around just the 10K to 100K scale on like estimated rewards and like what goes into that. I think Yaniv already answered one of the questions in chat that I guess it's specified in the indexer agreement that that's based on a independent valuation of the tokens shortly after launch. In terms of why that scale is so large, I'll just address that really quick. A lot of that's just contingent on us not knowing upfront how many indexers are going to make it through phase 0 and participate in the testnet. So which is kind of why there's a large range there. I mean, you can imagine that if more people participate, it's going to be more competitive. If and if less people, it's obviously going to be less competitive. But the other factors going into that, as we kind of said in the first kickoff call, is primarily you're going to be gauged in the later phases based on your ability to profit through the protocol. So that's going to be the query fees that you generate, indexing rewards, and subtracting from that are your hardware costs and other costs. In addition to that, there are these kind of subjective points that will be that I think Eva spoke to in the last call, and we'll be talking more about in the future, of just kind of being good citizens of the graph. So these can be things like filing documentation bugs. They can be filing bugs in our other repos. They could be participating in user studies on the product. And even though we see kind of the node operators as competitors in the context of the protocol rules, we also encourage you guys to sort of support each other. So I've seen a lot of requests for like archive node snapshots. For our own internal setup, we load balance across a number of external providers. So that's not something that we can share, but if that's something that folks in the community, want to share, like we will look to that as, in the points calculations as being kind of good citizens of the graph. Furthermore, this isn't something we've talked about a lot, but in the future, we're going to have a ambassador program. And so we'll also be kind of looking to who are the most proactive participants in our community in terms of helping other people, whether that's, we already have a lot of kind of shortlisted people on the subgraph developer side, but, as we look at the node operator community and we identify ambassadors to kind of represent the graph, that's also something we'll be looking at, kind of your citizenship, within the graph. So we don't see this as purely a competition. We see this also as kind of, like we said, moving beyond zero-sum games. Let's see.
There's one question about Postgres horizontal scaling. Whether we have any suggestions for doing that yourself, or whether we recommend a cloud provider for the Postgres instance. I think you can get pretty far with just a single Postgres instance, as long as it's configured well and it has enough resources in terms of memory and CPU. Can get really far. We do support read replicas now, which could be useful. We haven't really test driven that properly yet, but the functionality is in graph node. But on the experimental side, it's hidden in an environment variable, but you can specify a number of read replicas for that would then used, or in a round robin fashion will be used for queries. Won't be used for subscriptions, but will be used for queries. And I think that's all we're going to test in the testnet. So read replicas, that's an option.
Yeah, and I think it's unlikely that we'll hit even within our stress tests for the system. I think it's unlikely we'll hit a scale where we're maxing out like the biggest Google Cloud database instance, because there'll be so many indexers in the system. But it's definitely good to know that you have that option.
We are at the top of the hour. Do we want to take one more question before we close things out?
Yeah, I was trying to see if there are any specific ones that we haven't addressed. Or does anyone have any kind of pressing questions that aren't on topics we've already addressed? It looks like more stuff on hardware requirements. I think we should just take those to Discord since those are in the weeds. if there's nothing else, I think we can probably wrap up there.
Okay, great.
One
Yeah,
more
as
question
Brandon
about,
said, sorry, go ahead, Yana.
there's one more question about receiving agreement for new indexers.
Yeah, so if you've signed up, you should have already heard from folks on our team. If you haven't, please reach out and we'll make sure we get you the indexer agreement. That's something we're trying to get signed with everyone during this phase.
Great. All right. As Brandon said, any additional questions can be asked in Discord. We will address everything there. Thank you all for joining this call. We're really kind of at a pivotal time, and we're grateful to be kind of at the backbone of this future distributed internet that we're marching towards. So thank you all so much. We'll be sharing this recording after, as well as all the other requirements for getting that indexer agreement and beyond. Thank you.